Hi everyone, for this question it asks us to express the fraction as partial fractions, hence evaluate from lower limit 1 up to limit 2 for this fraction. So first of all, when we're doing partial fraction, we need to identify it is proper or not. For numerator, you can see this is power 4, denominator is power 3, which means that this is improper. Therefore, we need to do long division to take the proper part. So we need a multiplier of 2 and an x so that we can get 2x power 4 and then expand for this 2x squared. Then we eliminate this 2 minus 2, 0. This one we get 2x squared plus 1. So we can see this is quadratic, this is cubic, so the balance is smaller than cubic function. Therefore, for this polynomial division, it can give us a quotient 2x, and then remainder is 2x squared plus 1 over x cubed plus x. So this part only we will continue to express it in partial fraction. So for the second step, we need to identify our denominator x cubed plus x, factorize it completely. So now only we proceed to split according the factor of linear. Another factor is quadratic factor x squared plus 1. So linear factor up here will be constant, quadratic factor up here will be linear bx plus c. Next step, we're going to equal the denominator where a need to times the factor it don't have. Meanwhile, bx plus c times with the factor of x. Then for the next, we can start let x equals to 0, as we can see one roots here, where x equals to 0, it gives us 1, which is a. Then to find b and c, we need to let it twice, but when we let it twice, we can get simultaneous equation. So to avoid that, we use comparison method. So we expand it where a is 1, then bx squared plus cx. We compare for the coefficient of the term. For x squared, it will be 1 plus b. For linear, it will cx. For constant, it will be 1. So as we compare here, coefficient of x squared is 2. Linear, we don't have, which is 0. Constant is 1. So b is 1. C will be 0. So lastly, we get to express in partial where a is 1, bx is 1, c is 0. So this is the remainder part. So for the complete fraction, it will be 2x plus the remainder part, and come from the complete fraction, which is our questions here. Two x 4, 4x squared plus 1, So after we done expressing this in partial form, then we're going to evaluate this integral. To integrate 1 until 2 for this fraction, we take its partial fraction form, which is 2x, and plus with 1 over x over x squared plus 1. So this one we can integrate directly using formula. This is fraction formula number 6. So we check whether we have the pattern or not. If we want to integrate fx when our denominator is not linear, we want to see whether it has differential function at numerator. If it has this pattern, you can direct integrate, get answer ln of fx. So denominator function x squared plus 1. When we differentiate it, it's supposed to get 2x. So what we have is x, but we can modify the coefficient by timings 2 and divide 1 over 2 at the side of the fraction. So we have the pattern. This is f prime x, this is fx. So we can direct integral using formula special form number 6. So integrate 2x power plus 1 over new power. Integrate 1 over x, which is ln. Then this is 1 over 2 coefficient. So fx at prime x, it gives us ln fx. Then lastly, upper limit 2, lower limit is 1. So what we need to do next is substitute upper limit minus lower limit. Upper limit minus lower limit. Then we evaluate using calculator. So here we have 4.15. So that's all for this.